met Holt, who is the creator of the Caddy web server. So I personally, I'm a penetration tester, but also a little bit of a software developer, and I use Caddy web server wherever I can, also on my private server, and it's an awesome product. And the Caddy web server has one very specific, very cool functionality, which is automatic TLS. So you just deploy it there, and it's gonna automatically pull a TLS certificate from Let's Encrypt, and has awesome TLS default settings. That's why I love this product. And so I thought, I mean, it would be cool to hear firsthand from the main developer of the Caddy web server at SBA Live Academy, because it fits the topic very well. So with us today is Matthew Holt. He has a master's degree in computer science from the Brigham Young University in Utah, and he's also the lead developer of the Caddy web server. Matthew, thank you for being here today, and the virtual stage is yours.
Thanks, Thomas. Appreciate the invite. And thanks to all of you who are joining. I've never done something quite like this before, so it's kind of fun, and hopefully it goes well. So today I will just briefly introduce to you how Caddy helps to make the web more secure by being a web server that uses HTTPS by default. So as we get started here, I want to prep you, if you want to participate in a slightly interactive demo later, take one of your domain names that you have, and or make a new subdomain or something, and point it at this IP address. We'll use this toward the end of the presentation if you want to. So maybe take a note of this IP, because I don't think it'll be visible after I move away from this slide. So put it into your phone, or just paste it into a text editor or something, and then just go update your DNS record, set an A record for this address, and then you can participate later on. So I'll just give you a minute to do that. Yeah, but anyway, real quick background. Caddy is a project that I started in my undergraduate program, not as part of the program, but just like on the side, because I was scratching an itch, so to speak. And so that was about 6 years that I started that, and now it's actually it's seen a lot of production use, and it's also older than products like Kubernetes. So a lot of people hesitate to use Caddy because it's like this new thing, but actually it's been around a while. It's only a little newer than like Docker mainstreams, Docker usage. And so if you're using Kubernetes and Docker with no problem, you can use Caddy with no problem. But you don't also really need to use Docker with Caddy, by the way, because it's a totally static binary. So there's no external dependencies, and it compiles for like every platform. So anyway, it's amazing, because in 2015, Caddy got its first certificate by itself to serve sites over HTTPS, and that functionality is still fairly magical, which is really neat to just spin up your server and just see it get validated right away, and then serve over HTTPS. And maybe there's just something to like being validated that just feels good, but seeing that validation process occur automatically is still, it never really gets old. Okay, so hopefully you have this IP address written down if you want to use it, participate later. I will go over how the Acme protocol works. This is a protocol that was developed in the early 2010s, and is only recently formally spec'd as an RFC in 2019. I think last year it finally got spec'd. So this is the protocol that makes it possible for certificate authorities to issue certificates in an automated way. And Caddy abstracts all of this complexity away for you. By way of background, very briefly, most of you probably know that transport layer security gives you 3 guarantees: confidentiality, integrity, and authenticity. And these are important for communicating over untrusted networks. Now, the thing is that you can actually get TLS, or get transport layer security, yourself by issuing your own certificates. But you can't necessarily be sure that you're getting authenticity. You can't be sure that you're talking to the server you think you're talking to, or the peer that you think you're talking to, if you don't really do certificate verification. You need a third party to validate the identity for you. And so this is why it's a little tricky to get proper security out on the web. It's amazing how far we've come. I gave this talk back in 2016, so back when Acme was still very new and unformalized and stuff. And so I'm reusing some of these slides, but it's amazing how far we've come, by the way, in just these 5 years, where over 90% of the web is encrypted now by some measurements. And so anyway, now we have these third parties that can automatically give us authenticity and confidentiality and integrity as we connect to these various services on the web. So anyway, the point of this is that we do need a third party to do the validation for us. We can't do it ourselves and have the public just kind of trust our own credentials, you know. Now, the way this was done traditionally was very complex and error prone. You would have to, many of you know this very well, you have to do all these steps, mostly manually. You can write tools and programs to automate it. Now, remember back in 2014, 2015, even that was not, like, automating things was just not very common, was not very clunky. You had to do a lot of this process very tediously, and that's one reason why certificates are so long-lived. It's so cool, by the way, giving this talk in like the past tense, because last time I gave this talk, this was still very much the reality. Certificates lived for 1 or 2 years, and you had to do all this manually. Acme was very unknown and obscure, and there was very little tooling around it. And now 5 years later, it's a much better situation. Probably very few of you are actually performing this process, all of these steps anymore, hopefully. So Acme comes in and is able to, these are the steps, by the way, I'm highlighting here, the steps that are not easily automated or can't be automated at all. So everything in the middle here really can't be automated. And a lot of these steps here, these highlighted ones, are very error prone. People often get them wrong, or, I mean, clicking links in emails has never been dangerous, right? So these are the kinds of things that were problematic before, not to mention the cost. A lot of certificates would cost money. So Acme comes in, is able to simplify this process to these 5 high-level steps here. And all of them can be automated. And all of them have cryptographic proofs and seem to fulfill the requirements for proper DNS validation to get a certificate. Now, how this works is not, a lot of people don't necessarily understand how this works, but it's actually really interesting and important to know. There are 3 ways that a certificate authority can validate your identity as a website. And we call these the Acme challenges. And there's 3 kinds of challenges because they each serve different purposes and work in different environments. The HTTP challenge works over port 80. The TLS ALPN challenge works over port 443, and the DNS challenge doesn't use a port on your server, which is the benefit of it. So I'll just go over these really quick as well. The HTTP challenge, this is where your server will respond to an HTTP request, a special HTTP request, and serve a special resource at a particular location. This does require that your server is accessible on port 80 from external networks. But this challenge can actually be done manually. It kind of defeats the purpose, but 4 years ago, 5 years ago, that was a little more relevant, but nowadays it doesn't super matter that it can be done manually. The nice thing about this challenge is that it doesn't require any configuration. And typically most web servers are already exposing port 80, at least so that they can redirect HTTP to HTTPS, which, by the way, is something that Caddy does for you automatically. The TLS ALPN challenge is similar, except that it works on port 443 and operates only at the TLS layer. So you don't need an HTTP server running or any particular application. You really just need the transport, the TCP and TLS transport open on port 443. This does require port 443, much like the previous challenge. You can't get around that. You have to either forward the port or just use port 443. The nice thing here is that, again, you don't need to run an application layer service, and the way it works is the CA will basically do a DNS lookup for the domain that's validating, contact the server that the DNS record points to, connect to it on port 443, and then use a special TLS handshake, use the AOPN extension, I guess, the TLS client hello, to negotiate to validate basically ownership and control of that port. So again, this requires that your server is accessible from the outside. This is not something that you could really perform manually, which is fine. But the other nice thing is that there's no config required. So like this and the HTTP challenge before it, they can just work. You really don't need any configuration required. So that's kind of the magic here. Now, the last challenge type is nice if you are not able to expose any ports publicly, or if you need to, in Let's Encrypt's case, to get a wildcard certificate. The DNS challenge basically sets a particular record in your zone file, and then the Acme server will just validate that that record is a certain value. So this is nice because you don't need to open any ports. You can do this manually if you needed to. You can often automate this though. In fact, like most of the time it's automated because most DNS providers have an API. And there's a lot of tooling that will work with dozens of DNS providers. So almost surely your major DNS provider is supported. But some DNS providers can be really slow to apply changes. We've seen that some validations can take on the order of hours instead of seconds, which isn't awesome sometimes, but I mean, if you need this challenge, that's the way to do it, and you can talk to your DNS provider to get that resolved. But this one does require some configuration on the server side. You need to configure your web server with credentials for your DNS provider so that it can access the API, and they can be scoped credentials. You know, it doesn't have to be anything super like global access kind of thing, but again, that's all up to your DNS provider. So these three challenges together allow you to get certificates in basically any environment that are publicly trusted for any public domain name. And then of course, all certificates go to transparency logs. So it's not like domain names are secrets, especially if they're publicly trusted, they can't be secret. So those are the three main challenge types. And so Caddy supports all of these. And since all it really needs to do them, at least the first two challenges, is a domain name, it can actually just work by default. Caddy kind of raised the bar for, or set the standard, I guess, for this back in 2015, when it became the first server to use HTTPS automatically. It was like the day of Let's Encrypt's public beta. I pushed support for automatic HTTPS, which is really cool to have been working on that for a few months before and get that working, because you literally just give your web server the domain name that it's serving, which you give most servers anyway, so they can route requests properly. And the only difference is that it's on port 443, and it does the redirects for you and gets a certificate and keeps it renewed. There's a lot of implications here that I could go into, and I might here in just a bit, but I just want to make sure that we understand that the minimum required config to get automatic HTTPS to work these days is a domain name. Yes, there's a lot of details, but they can all be set by default. For example, you can set the default certificate authority to be Let's Encrypt or another Acme-enabled CA if you want to. There's more than just Let's Encrypt these days, but I think they're mostly commercial rather than nonprofit, which is fine if that's what you want. So we also recommend that you provide an email address so that the CA can contact you if there are problems with your certificate. But at least as far as Let's Encrypt goes, the only reason that they would even use your email address is to contact you if there's a problem, which is actually a really nice courtesy and keeps things running really nicely. And then there's lots of crypto knobs that you could set. like key types and things like that. And there's a lot of management policies that you can configure. But again, a lot of these have really sensible defaults that you can just set. So really all a web server needs is a domain name. And all web servers have that anyway, basically. So let's show you how this works. Okay. So I will. Okay, so yeah, I'm logged in as root, but for the demo, I don't really care. YOLO today. So to show you how this works, I've got Caddy installed in this machine, I think. Yep. It's one of the latest versions from master, which is actually going to be released here pretty soon. Hopefully you can all see this. So I'm going to show you how this works by making a Caddy file. I haven't actually tried this yet, so I hope this works. The first line of the Caddy file is always the site to serve. So in this case, it's going to be demo.https.dev. And then I'm going to just respond to all requests with hello world. So that's my Caddy file. Don't really even need a whole config file for a simple demo, but and then I'm gonna do, now because there's a Caddy file in the current directory, I can just say Caddy run and it will pick up that Caddy file and use it. So I'm gonna cross my fingers here and you can see that Caddy is getting a certificate. You can actually see the multi-perspective validation going on here, which is really neat. So Let's Encrypt now does validation from multiple perspectives on the internet. And they'll, just to make sure that no one is BGP hijacking or messing with DNS perspectives in just a single place. So anyway, you can see that this worked. Now, I'll show you here. If I do http demo.https.dev, I get a redirect to HTTPS. If I follow that redirect, I get this hello world response. So everything is working great. So in a few seconds, Caddy got my site up and running on HTTPS, which is more than any other web server can really say. I'm kind of surprised that like 5 years later, no other web server is using HTTPS by default. Yes, there are several that will do it automatically. And there are even more that will do it with extensions and plugins like compiled in, and then you can hook up extra tooling. But anyway, oh, and maybe some of you are already trying the interactive part, which I'll get to in just a minute. But anyway, yeah, so other servers, they don't have this capability built in to where it's like automatic. Usually you have to at least turn it on by flipping some sort of switch, but with Caddy, as long as you just provide a host name, it's gonna work. Okay, so now let me change the configuration. I'm gonna stop the server here. And I'm gonna adjust the Caddy file and I'll show you another cool little thing. So let's suppose that I want to set up like a little, some sort of SaaS product, and people can bring their own domain names. This is a huge deal, by the way. Like no other server does this. I just want to serve my customers' domain names, and maybe I just proxy it to my service or whatever else, or serve some sort of static directory. The point is, I need to listen on port 443, and I need to serve all their domain names over HTTPS. I don't know what their domain names are ahead of time. I will once they like enter it into my system and stuff. But when I'm setting up my server here to like put my site online, I don't know what their domain names are. So I can't put it in my config file. And also, even if I do know what their domain name is, I don't know if it's properly configured. Like it needs to point at my IP address. Obviously, I can give them instructions. Great, go ahead and set your A record to, you know, this IP. But I don't know when they're going to do that, or if they're ever going to do that and actually start using it. So I can't just add their domain name to my config file and have Caddy get certificates, because the validation would fail. Well, I can enable what's called on-demand TLS, which is something that we kind of pioneered here. This has actually been in Caddy for like 5 years, so this is not something new, but we've been improving on it. And instead of actually setting up a real SaaS or proxying, I'll just respond with welcome to and your domain name. So what this Caddy file does is it listens on port 443, and then on demand, it will get TLS certificates, and it will respond to requests with the domain name. Now, what does on demand mean? Well, what this means is that the first time that a TLS handshake comes in for a particular domain name, Caddy will try and get a certificate for it. Now, this feature can be obviously abused since any client can just spam a server with requests for various server names. So typically what you would do is you would enable either both probably rate limiting, and then there's a feature called an ask endpoint where Caddy can make a quick request to some internal endpoint and ask if it's allowed to get a certificate for this domain name. And so we strongly recommend anyone deploying this into production actually uses this feature so that you can like check your database and make sure it's a domain name that you're servicing. Excuse me. Otherwise, that could be bad. But for the demo, I'm not going to enable that because it's just for a few minutes here. So then I'm just going to say Caddy run. And you'll see that now if you were participating in this interactive portion, you can access your domain name that you've pointed at this IP address, and you can see that Caddy's getting certificates already for a few of your domain names. And so, yeah, so that looks like it's working, hopefully for all of you. Anyways, yeah, so that's kind of a cool feature. So if you visit your domain name, you should see, I actually didn't set up any other domain names for that. But you can see that my original one, demo.https.dev, is. So there you go. I've spent about 2 minutes setting up this like really complex SaaS integration, so to speak, that most of you would probably spend several days or weeks trying to get right. But Caddy will just kind of manage certificates for your customers' domains as they start using them, which is really neat. So anyway, that concludes the demo. Hope you thought that was cool. Okay, so I just want to finish up here by going over like some of the challenges that we encounter in production. And there's actually a lot. When we first launched this in 2015, we thought, oh, this is cool. Like, this is great. Just go use this. And yes, like that's the case. But at the same time, there are a lot of things that we've learned since then can go wrong. For example, CAs impose rate limits for good reasons. A lot of scripts tend to be very like kind of runaway scripts where they get stuck in infinite loops or whatever. And so rate limiting is actually really important, and we need to respect that and expect that as well. Failed validations happen a lot. I think you saw some of that in the demo. You can point non-existing domains or send TLS handshakes to non-existent domains or misconfigure a server, and it will fail validation and not be able to get a certificate. Well, what do you do in that case? Revocations, we saw this happen recently, actually. To do this mass revocation in the order of millions of certificates. And it's like not a big deal really, because like that's what you gotta do. But if your certificate is revoked, it's no longer trusted by browsers. And so if you don't renew it for another 60 days, you're gonna get cert warnings or security warnings on your site for the next 60 days, which isn't acceptable. And the list goes on, obviously. But I'm really pleased to say that Caddy actually handles all of these cases And it's the only Acme client that I know of, the only web server that I know of that can actually handle all these problems. For example, in the case of revocation, Caddy will detect that because it automatically staples OCSP responses to every certificate. It can detect when the certificate has been revoked and just renew it or replace it. So Caddy wasn't affected by that. Infrastructure outages happen. We've actually seen major sites go down where because of OCSP responder outages or CA outages. But again, Caddy can handle all that because it caches OCSP staples to disk, or it renews certificates 30 days ahead of time. So you have plenty of time to resolve outages. We showed you how it handles customer domains where you're not in control of the domain name, but you do need to serve it and serve HTTPS for it. You see the case now where Caddy can handle that. We've seen cases where storage is misconfigured. So Caddy can get a certificate, but it can't save it to disk. And so when you restart your Docker container to, if you're scaling up and down, it has to keep getting new certificates, and then you run into rate limits really fast. Well, Caddy solves that problem too, because it checks to make sure that the storage can be written to and read from before it. Caddy can also coordinate certificate management across a cluster. So you can put 2 or 10 or 100 Caddy instances behind a load balancer and have them all serve the same domain name. And as long as they're configured with the same storage backend, Caddy can download, can coordinate the management between all of the instances. So only one instance will end up actually doing the validations, but all the instances can solve the validation, which is really cool. So you don't have to route the validations to a particular instance. It just kind of works. And it also works with up to millions of domains. We have customers who are using it at tens of thousands of domains just fine. I'm pretty confident that as long as your hardware supports it, obviously, you can do millions of domains, because Caddy has a lot of good internal throttling and pretty smart synchronization of renewal jobs and things like that. And if validations fail, Caddy will retry. So it does exponential backoff, and it will retry. And during the retry, it uses Let's Encrypt staging endpoint, or you can configure a different test or staging CA for these cases where the staging rate limits are much higher and don't count against your production rate limits. So retries, for example, if your domain validation fails just because you forgot to set your DNS record, no problem. Caddy will see that it failed once, and it will then retry. It'll back off on the staging endpoint. And once it sees that it starts passing its staging, it will switch back to production and give you a real certificate. And also we try all the different challenge types that are enabled and configured as opposed to just one. Anyway, there's a whole lot of things that have gone into improving the automatic TLS support over the years. And as far as only Caddy offers these features. So when people ask if Caddy is production ready, the answer is yes. Way more than your homebrewed hack together cron job, certbot, Nginx thing. Yeah, it's way more production ready probably than that. Caddy sites have stayed up when other sites have gone down, and that's just kind of the fact. So, so I'd like to say that we are well on our way to making automatic. This is a good model. This works. So anyway, that's pretty much what I have to say about that. I hope that you will try it out. If you haven't already, Caddy 2 will be released next week. And thank you very much for your time and attention.
Thank you, Matt, for the great presentation and the live demo. I'm not sure if you mentioned Caddy 2 is open source, so it's free to use for everybody. Yeah. So that's just to make sure that everybody knows.
Thank you. Yeah, that's a good clarification.
Yeah. There is one question that's in the Q&A section. It is, are the certificates stored as files? If I restart Caddy, it will not fetch cert from Let's Encrypt, right?
Yes, yep, that's correct. So all certificates are immediately stored to disk after they're received. and they're just files on disk. So you can restart as long as your storage is persistent. That's really important when you're working with like Docker containers or something. Make sure to persist the storage. But yeah, you can store it as files. If you can also configure different storage backends. So if you want to use a database, you can do that too. It's pluggable and modular.
Mm-hmm.
Yeah.
I have a question as well. Why would someone prefer the DNS challenge over the other two when the other two work out of the box? Is there any reason to prefer the DNS challenge way?
Yeah, great question. DNS challenge is currently the only way that you can get a wildcard certificate from Let's Encrypt. That's a Let's Encrypt enforced limitation, not a protocol limitation, as far as I understand. It's just an extra conservative measure to ensure that you actually control the DNS like zone for that domain instead of just a port, because with wildcards, it's a little bit of a different question as to what that means as far as ownership and control. So anyway, yes, so if you want a wildcard certificate, you need to use the DNS challenge. And if you don't want to expose any ports to the internet on your web server, you also need to use the DNS challenge in that case.
Mm-hmm. The next question is, very excited for Caddy 2. Will the build server go online next week as well to add plugins?
I have started writing it. It won't be ready by next week, but I want to see that soon, because that makes the download page really nice, right? You can just point and click at the plugins you want to add and then just download, and a few seconds later you get a custom Caddy build, which is really cool and important, I think. So it's in the works. In the meantime, we have a tool this time, and we didn't have this with V1 really, but we have an official tool now called Caddy that makes it really easy to build Caddy with plugins. It's strongly versioned, and it's a really easy to use command line tool or Go library. So look into Caddy if you need that in the meantime.
Okay, I'll go to the next question by Thomas. Is it mandatory that the TCP port 80 is open and active, or can it be replaced by another one?
Oh yeah. So the Acme spec hard codes port 80 and port 443 for the HTTP and the TLS ALPN challenges respectively, and that cannot be changed. So the Acme server, the CA, will use ports 80 and 443 when they talk to your server for those challenges, and that's the only way to do it. So if you need to listen on a different port, you will have to find a way to forward those ports to a different port.
Mm-hmm. Many more questions coming in. I hope you have some more minutes to answer those.
Yeah, that's fine.
Erich is asking, can I use Caddy instead of Apache, and is it easily integratable with Spring Boot apps?
I don't know what Spring Boot apps is, but probably. So Caddy, yeah, you can use Caddy instead of Apache or Nginx in most cases. It depends what your exact use case is and what your configs look like, but Caddy, if it can't do it now, it's like capable of doing it. Someone might just need to write the code for that particular module. But it's most often used as a static file server or reverse proxy. So you can do either of those. It's a very capable reverse proxy and file server in either case. So the answer is almost surely yes. In fact, you can even serve PHP with it, as long as you have like PHP FPM running. So similar to like how Nginx serves PHP, Caddy can do that as well instead of Nginx.
Isn't there an import module for configurations of Nginx as well? I think I read about that.
Yeah. So you can, if you're using the Caddy file, you can say import and then other files. Mm-hmm.
Okay. Well, from my own experience, I can say I've been running Caddy since years now, and it's almost certainly going to make the configuration more readable and shorter than what you would have with Nginx if you want to come up with the same secure TLS configuration. So I also can confirm that it's almost certainly yes. The next question, if I run it in a cluster, how are the certificates shared? Is this done by Caddy itself, or do you need to sync or share certificates somehow by yourself, on your own?
Also a good question. This is a kind of a cool thing about Caddy, is that it will kind of just work. So as long as you configure each Caddy instance in your cluster to use the same storage backend. So by default, Caddy will use the file system, the local file system as its storage, which is a reasonable default. But you can change that directory to a network shared mount, for example, that all the Caddy instances in the cluster are using. You can swap out the file system configuration for a database. I know there's adapter or file storage implementations for like DynamoDB and Redis and Console and maybe a couple others. And so you can just change a couple lines of your config and use one of those as a storage backend. And so what'll happen in that case is that Caddy will just write the certificates and other assets like OCSP staples, etc., to whatever storage you've configured. And as long as all the Caddy instances in the cluster are using the same configured storage, whether it be a file system directory or a database table or whatever, they will see the files that are there and just use them if they already exist. So yeah, it should just work. It will also do its own locking. As long as the storage backend provides atomic operations, so like S3 does not make a great storage backend because there's no like transactional support or like atomic operations as far as I know. I might be wrong, I hope I'm wrong, but as long as it provides atomic operations, yeah, it can synchronize across the cluster just with storage.
Okay. Still more questions. If you have to run, just let me know, and then we will stop. But as long as
this is fun.
I'm gonna keep asking those questions. Thomas is asking another
Sure.
question. Is there any performance study comparing Caddy version 1 and version 2 with other web servers like Nginx or Apache 2?
Yeah, so I get this question a lot, and I have many things to say on this matter, but the short, succinct, and hopefully the most helpful answers are that Caddy is going to perform about the same as any other Go server out there, because we use the Go standard library, obviously, which comes with all of the memory safety guarantees, etc., that you don't get with Nginx and Apache and OpenSSL and whatnot. So it's never vulnerable to like Heartbleed and all those other things. Performance-wise, any Go server is going to perform about the same. Also, that's really difficult to answer generally because web servers are very complex pieces of software. And so my answer is that it performs well. And Google's using Go in production. And I think if Google can use Go in production, you can too. You'll find that Caddy doesn't add like almost any extra overhead, and that for 99.99% of sites, you'll be fine. Like unless you're the Cloudflare of the internet and you're hardware constrained, you probably are not going to have a performance problem with Caddy. You can chase benchmarks all you want, and we can like try and like squeeze out certain, like the problem with benchmarks is that it doesn't really prove anything. Like there are literally tens of thousands of parameters related to performance testing, especially things as high level as a web server, because you've got the Go runtime or the web server's runtime in general, even if it's like the C, runtime, so to speak. And then you got like the operating system configuration, you've got all the parameters of the system, the network stack, you got the hardware, processor optimizations, all these things that affect the performance of web servers that really don't mean anything unless you're like chasing benchmark results, which isn't really a productive use of time for people who want to get stuff running in production for like real use cases. So what I'd recommend is put it into like a staging environment and see how it works, test it out, and if it works great, then use it. And if it doesn't, if your web server is a bottleneck in 2020, let's talk, because that almost should never be the case.
Yeah, I was going to say that the bottleneck is almost likely somewhere else and not in.
Yeah, in fact, someone the other day just posted a tweet. He runs a couple of SaaSes on Caddy, and he did some testing and found that Caddy was like way faster than Nginx with OpenSSL in his use cases, probably because of like crypto, like Cipher Suite, optimizations or whatever, but he found that like Nginx is only performing at like 5% or 10% the speed of Caddy with in his particular performance tests. So your mileage may vary, but it's going to be very good.
Next question. At cipher suits level, is Caddy version 2 optimized to use those more secure ciphers by default?
Yes. So Caddy's default TLS configuration is secure. You can test that using like SSL Labs server test, or Mozilla has an observatory tool for that too.
Okay. Paul is asking, with Caddy version 1, one had to provide an email address and the --agree flag. With Caddy version 2, only the email address is configurable, optional inside the Caddy file. How will Caddy handle challenges without email? And is it good advice to provide the email address?
Yeah, so the email address is optional, but if you provide it, the CA will be able to contact you if there are problems with your certificate, including expiration emails. So if for some reason your web server is not able to renew your certificate, for example, if it has trouble with DNS validation, because remember, we talked about there are a lot of external factors that prevent renewal as well sometimes. You can get emails basically if those happen. So we do recommend, it's also a nice courtesy, like especially if you're using Let's Encrypt, the CA is providing something to you for free, and it would be nice to help, like to work with them to help resolve problems if there's any issues. So we do encourage sending email, but it's not required. Yeah, they're totally private, like Caddy doesn't use them.
Yeah, from my personal experience, it was helpful in one situation where the server was not able to renew the certificate, and then I got an email after a while by Let's Encrypt telling me that there's something wrong with the new renewal and the certificate wasn't renewed in a certain time frame. So it's useful.
Yeah,
you can just use any email address. It doesn't have to be your private one. Just use register any Gmail address for anything like that.
Right.
The next question is about the server name unification challenge. Is the TLS SNI challenge deprecated?
Yes. Yep. A couple years, I think a couple years now, it's been deprecated because of a weird kind of edge case with like big cloud providers that, made it, that showed that it was more common than we thought that the TLS SNI challenge could be abused. So anyway, that's been fixed.
Mm-hmm. Kenny is asking, is there a Ubuntu PPA to install Caddy?
I think there is as of yesterday, actually. I'll go to our install page, and I think I just published I'm looking it up right now. We just published yes. Can I put the link in the chat? Is that go to people?
Yeah, you can send it to all panelists and attendees using that dropdown. Then everybody's supposed to see the link.
Got it. Okay, so it's in the chat. There's a link to that. Francis worked hard on that. And this is like very first, we're just trying it out, the PPA here. So at least I think that's what it is.
Okay, Thomas is still actively asking questions. How does Caddy version 2 handle security headers?
Yeah, the same as Caddy 1. You can set them. We don't set the headers for you, just out of caution, I guess. Like we don't want to accidentally set X HSTS, whatever that header is, the HSTS header, because we don't know that your site is going to be the same, like served over HTTPS for that long. Like, yeah, we hope so, but like, we don't want to like brick your site, just because you ran Caddy once and then, I don't know, changed your mind or something. So yeah, you can set the security headers. I recommend that.
All right, so I think that's it. There's one thing it's hidden in the question. It's not a question actually, but somebody's recommending test ssl.sh, which is a shell script that you can use to test your ciphers. So I'd suggest just fire up a Caddy server locally and point the test SSL instance there, and you're going to see that the ciphers are actually pretty well set by default without you changing anything in the Caddy file. All right, Matthew, thank you very much for being here and for taking the time also to answer all those questions, which took almost as long as the talk.
Oh, wow, yeah.
Thanks for sticking around, and thanks everybody for attending.